I met Stan at Photonics Europe last year, and he was actually one of the winners of the first optical design contest that was running at Photonics Europe. Very talented guy just out of college, and he's going to talk about his device, the Lynx, which is developed by SL Process. It's a company in France. So Stan is a 24-year-old computer scientist, works at the intersection of hardware, computer vision, robotics, and real-time low-latency software and 3D rendering. And I see that he brought his Lynx headset.
Yeah. Okay. Thank you, Bernard. Hi, everyone. Thank you very much for listening to my presentation. The work you're about to see is a 2-year-old effort of making video see-through AR or MR headsets, whatever you call that. So those are the schematics I started with. This is a 3D model I use for 3D printing. It's a very simple architecture. It's basically a VR headset with a custom stereo RGB camera and a lip motion and all the sensors we'll see after. So that was me in Paris yesterday, mounting the prototype you see here on the table. And this is how I deliver my customers. This is what you call the beta version. And for some customers, we are delivering this so the developers can start integrating their applications. So I'm using, of course, 3D printing. I don't have the needs for molds yet. This will be for the version 1. And this is the photo of the product, untouched without Photoshop. And this is the photo of the product. Again, in Paris. I'm the only developer in my company, and we are 4 now, and we're expecting to be 10 by June. So the challenges of AR video pass-through or see-through headsets, I only listed some of them. There are much more, and I have to think of this matrix every time I take a decision on my system. You will see there are many issues that you find also in optical see-through devices, like HoloLens, for example. I benefit of the VR world, where there are people way smarter than me that are working on some of those issues. The last talk was one of them, for example. So what I try to build and what I deliver is a 100-degree horizontal field of view headset that is working. When I see my device, I see 1,000 things that are wrong. This is the beta version. So you have 30 seconds to take a picture of the specs here, but those are the specs of the actual device. And we'll talk about some of them and how I could achieve the performance for some aspects. 2 challenges I faced when building this was the tracking, was the world anchoring of objects like visual odometry or SLAM. It took me 9 months to write the software for tracking. It's here. So on the left, you see what the left eye of the AR headset sees, and you can see that I can draw in 3D, and the drawing is fixed. So it's quite robust, actually. It's 30 Hz tracking on the mobile architecture. And the drift you're seeing, there is a drift. I see it, and it annoys me, is because at the time, my IMU and camera were not hardware synchronized. And the time offset was varying over time. So it was very, very frustrating. So I built a custom hardware synchronized IMU and stereo camera with a simple microcontroller that will ship in the version 1 in June. Fortunately, the world of VR and AR that is trying to tackle the 6 degrees of freedom problem there are actually other people who have the same problem in the micro-aerial world. So there are great resources and PhDs around the world, from Zurich, Munich, and now Hong Kong. It's funny because when you look at the history of tracking, of inertial and visual tracking, people say it was in the 80s with Raja Chattia, who was French, who made one of the first systems. But in my opinion, and what I read in the literature, one of the best systems was actually an astro-inertial unit that was used in the Blackbird in the 60s. So we haven't invented anything. Also, for the computing power and efficiency, I had to do 3D stereo rendering at least 60 Hz in the same time tracking and in the same time combining all the sensors for sensor fusion. And I managed on the software side to fit all of this in a new architecture that fits at the back of the head. So my system is quite balanced. You have half a kilogram at the front and half a kilogram at the back of the head along the spine. I have good feedback for the first users. So those are some challenges. You know all the challenges. I will talk now about the opportunities and what I'm seeing on the field with people using my products. So you have, of course, the customer pain point that we're trying to solve, but those objects, the AR see-through devices or VR, this form factor brings a lot of emotion with it. It's something you put on your head. It's a black box, and it has this very high social impact, and we will talk about one of the customers. So those are some customers. Actually, Chanel didn't buy my headset. They bought my tracking technology. Chanel, why not? So this is one of my customer. He's doing 800 operations a year of open heart surgeries. He's an extraordinary man. He's 60 years old and is working in Paris at Hôpital Bichat. He reached me in my office and said, I need your headset. And I was the first one to say, you're never putting something on your head with my responsibility. And he said, you have to come and see what I'm doing, and you will see that you can help me. So next, I won the Selfie Award of the Year. He brought me in the operation room, and we are designing an interface of mixed reality using my headsets. I had to understand everything about his job. I can't reproduce anything, but I understand everything that is going on now with those guys. It's half a day per week for 6 months, and I saw all the things you can see in those operations, good or bad. So I'm here. We've been doing this in Paris and Canada because there is a big cardiovascular center in Montreal, actually. And this is one of the proudest photos of my life. This is him 6 months later using my headset, putting on such a cumbersome device on his head and being happy about it. Yeah, thank you. He's using for remote assistance, for also, it's actually a very easy optical problem. He's not moving, he doesn't move. It's a fixed focus, 40 centimeters plane of work. He doesn't need all the field of view of my headset, so we made some experiments about it. It's very exciting. And he's a reference in his job, so I'm waiting for good feedback for the next year. So what's next for this kind of device and my company? So as a company, I told you that we expect to be 10 people by June with some millions in funding that I secured this month. The V2, actually the V1 that will come in June, I told you that we will have a custom visual inertial sensor that is very important for our tracking technology. And I redraw a lot of the outline of the device for comfort. And it's very different from what Bernard tried last month at CES, and it's in Photonics in Strasbourg. The V3, it will be a completely different form factor, and it will tackle some challenges that were enhanced during some other talks. So thank you very much. This is the headset. It's something real. It's used in the field. If you have any question, I'm open for it.
Thank you. Thank you, Stan. And this is really important for us at the SPIE to see young people like Stan starting with an optical design contest and coming with some ideas and winning a prize, and then continuously focusing on the technology, not only one part of the technology, but in Stan's case, the entire headset, from the displays to the lenses to the electronics to the SLAM to the gesture sensing to everything, and then on top of it interfacing with the application, in this case with the surgeon, and understanding exactly what that particular application needs and optimizing the hardware for that particular application. I think that's amazing, and it requires a second round of applause. So
there was no blood, but a lot of tears and sweat in this work. Thank you, Bernard. I wanted to throw it by the window a lot of times, but it's...
I can understand. Do we have a question for Stan? So I have a question. How does this compare to all the other devices that are out there? Of course, there are not many video see-through devices out there. Intel had a project Alloy that was actually terminated. So how does this compare to others that are out there?
I've never tried Alloy, a project from Intel. I've seen
you can ask Ron. He's sitting right in front
I've
here.
seen what Virvana was doing with their Totem headset that was bought by Apple 2 years ago, and they were doing FPGA on the cameras for very low latency. It was a very great product, but today I haven't seen any other product like mine with customers, at least maybe in some labs, I don't know, but it's a completely different architecture from what we're seeing in optical see-through, but
how is the gesture sensing done?
The gesture sensing today is done with lip motion. We're working on their next hardware as well, and we have some customers that cannot use the lip motion in some areas. So we're using a much more primitive 2D RGB analysis of the image to find. I don't have the kind of sensor you have on board of HoloLens. I don't have any time of flight or Kinect for this kind of things. So that is why I use the lip motion.
And what's the field of view?
The field of view of
the gesture sensing.
Oh, it's 140 degrees. It's kind of ridiculous because the field of view of the headset, the visual field of view is 100 degrees. So the gestures is wider than the visual you get in the headset. And for the next version, it will be 185 degrees. So quite fisheye.